Good morning, everybody. My name is Doug Kling. I'm a sales engineer at Long. I have worked out of our Fort Collins office for just over 17 years this year. Prior to that, I spent a little over 8 years working for Train. My co-host today is Matt Kent with Q-PAC. Obviously, Q-PAC is going to be the topic of our discussion. I'll talk a little bit more about my experience with Q-PAC at the end of the presentation, but I recently discovered them on a very personal basis because I dealt with them directly between a major manufacturer and the company. I'll save most of that for the end, but I can't say enough good about Q-PAC and their capabilities and their support. And speaking of support, I will now hand this over to Matt Kent, who is the CEO of Q-PAC. Thank you.
Thanks, Doug. I'll try to move quickly so you have some time at the end. I have a background in mechanical engineering. I landed in the HVAC industry fresh out of college, primarily focusing on the application of new technologies in custom air handling units, and one of which being electrically commutated motors. So Q-PAC's been around for about 8 years. We're based out of St. Augustine, Florida. We just moved into a brand new 34,000 square foot manufacturing facility. We have roughly 42 people right now and constantly adding to the team as we grow. Everyone here is incredibly passionate about building the world's best fan system and just delivering innovative technology. So a little bit about fan evolution. Many of these probably look really familiar to you all. Starting with, constant CFM systems using belt drives, single large fans, and then evolving to more direct drive plenum fans paired with variable frequency drives, and moving to arrays of smaller direct drive plenum fans. And now we're starting to see a lot more ECMs, or electrically commutated motors. Some challenges that the industry faces: air handling unit disruption. I'm sure some of you have been involved in seeing a fan fail and really wishing that you had redundancy at that point, scrambling to try to put together a team, get the necessary equipment, whatever replacement parts, to get it back online to reduce the disruption in the occupants. So that's one of the big challenges. Another challenge is just efficiency. Many systems are still running on 30-year-old technology. It could be very antiquated and old, outdated, inefficient, and maybe was improperly sized to begin with and could be very oversized. So that's where we come in. Like I said before, we've focused a lot of attention on the application of the fans. ECM fans have been around for a long time, but now that they're seeing more and more applications, people are getting introduced to them and the complexity that they come with. They're basically a direct drive motor, a permanent magnet motor, with a drive built in, a variable speed drive, so you can send a 0 to 10 signal to them and change the RPM without requiring the VFD. One of the two major key features of our product are our wall and the modularity to it. I'll talk more about that in just a minute. And then our wiring architecture, which really is probably the single biggest piece to solving the complexity around EC fan arrays. So our wall, we have a few patents pending on our design. We put a lot of effort into simplicity, reducing the piece count, the number of parts. Our systems go into brand new air handlers, or lots of retrofit replacement, old fans being torn out and replaced by our system. So it's really important that you put a lot of emphasis on the installation process. We have developed in-house with our engineering team our own algorithms and software to where we can automate everything with just a few inputs to really streamline the manufacturing process using our CNC machines, press brakes, turret bunches. And like I said, little features go a long way. The right picture on the bottom is our little fan ledge. It's really simple, it just relieves the weight of the fan as you're installing it so you can bolt the fan in without having to fight the fan weight itself. ECM fans, there's a lot to talk about. I won't go into all the details, but I'll hit the key points. They're very compact and small and lightweight. This helps get them very well balanced, and because they're well balanced, they can be rigidly mounted. And since they can be rigidly mounted, you can make a structural wall, and you can reduce the complexity of the steel that's necessary. You don't need spring isolators, and you can shorten up the footprint, and they're easy to get out of a small access door. Many people think that they can't achieve high statics, but that's just not true. We have some fans that can get up to 9.5 inches and still produce a decent amount of CFM. They're inherently redundant, just like any fan array. The ability to put in an additional fan, if you can fit it, just in case one fails, really goes a long way. A few other notes, like I said before, they basically have a variable speed drive built in, so no need for VFDs. They're more efficient at part load than a traditional AC motor paired with a VFD, and they have a soft start factored in as well. So no high starting amps, low vibration, and hand carryable. So our Quick Connect wiring that I mentioned earlier, on the left you'll see the Quick Connect box. This has really enabled us to simplify our system and just fan systems in general. So by having this box here, we're able to automate the wiring and all the lengths to each motor, which allows us to factory wire every single motor and have it for a plug and play solution. This really eliminates a lot of the complexity around the electrical scope on projects. Currently, people may buy ECM fans and get them to the job site and still be confused on exactly how they're going to be wired and what type of wire or cable they're going to be using. And we really just try to simplify that and make it as easy as possible. And the Quick Connect is a huge part of that. Our control panel, so we have a single point of power and connections for the building automation system. There's a couple key points on the right. We try to cover the basics and keep it simple. Like I said, we don't want to make it overly bloated with too many features that people don't necessarily need. You can conveniently locate it wherever you want. That's where the Quick Connect really plays in as well. You can mount the control panel on an adjacent wall or on the air handling unit cabinet, and the electrical scope is simplified to where you can just wire between the control panel and the Quick Connect. Some of the key points that we focus on while working with Q-PAC is the design, the installation, and operation. We really try to simplify each one of these areas, whether it's design time, being able to get rapid response and rapid CAD drawings or submittals, and the installation, just simplifying it, making things safe, easy to carry, less tools, and operation as well. A lot of the algorithms that I mentioned earlier, they make it very easy for us to make our selection software for our manufacturers reps. This allows them to get back to their customers really quickly with designs. Any type of deliverable, you can download the CAD files straight from the web-based tool. Installation, our product is a kit, so it ships as packaged up as separate pallets. So we take packaging really seriously. We build a great fan system, and the last thing we want is for it to show up damaged. So we put a lot of pride into our packaging, the way things are organized, how the user's gonna unpack it and put it together, and just try to simplify that process. And then if anything does go wrong or happens to get damaged, or if there's any need for support in the field during the installation, we have a dedicated support staff 24/7. And if one of them is not available, even our engineers will get on the phone nights, weekends to help support the installation process. And if necessary, if it's a critical application, we can even budget in field supervision to have someone on site to make sure everything goes well. In terms of the system operation, efficiency is a big one. There have been some applications that I've seen a reduction of 50% in power consumption, just depending on how bad the old system was, and maybe it was oversized or different factors. Maintenance, incredibly low maintenance, really no maintenance. You may want to dust the blades from time to time, maybe once or twice a year. But other than that, it's very maintenance free. We've also seen cases where customers will run fan systems for more than a year, a couple years, and realized that even the new Q-PAC system is a little oversized. So we'll work with them to iterate the system, potentially remove some fans to store away as spares just in case one fails in the future. This increases the load of each motor and improves overall efficiency. That's pretty much the high level Q-PAC story. Thanks for attending. Thanks for the invite. And the coffee break thing is really cool.
Thanks, Matt. I appreciate it. Reminder, if any of you attendees outside of Long want to talk more about Q-PAC or learn more about Q-PAC, feel free to reach out to your individual sales engineer, and they can surely get you that information. And join us next week when Ryan Nedbalski out of our Colorado Springs office will be talking to everybody about Denlar hoods. I said I would go over a brief project, my exposure to Q-PAC. Prior to this job, my exposure to Q-PAC had been only through OEM agreements, which they have with several large and mid-size, both custom and non-custom. Brody, could you turn that? Brody. Sorry about that. But they have OEM agreements with lots of manufacturers out there, and my project, they did not have yet an OEM agreement with a large custom air handling unit manufacturer, but we were able to expose it to the ownership group because of the nature of the job and also the recent interest of the ownership group. There were 10 large air handlers on the project, over 155 total fans in fan arrays. In the base bid, every single fan had a dedicated VFD. So you can imagine the amount of electrical wiring required and the amount of controls wiring required to each individual VFD. We worked with Q-PAC to present the ECM fan array option to a relatively leery client that wanted to understand the technology, but that was also very scared to step away from the same thing they've been doing for years. The initial price tag difference was significant, but we still had an owner that was very concerned about stepping into the unknown, primarily, you know, having heard how hard it is to get replacement ECM motors, which was a real deal back when ECM motors first started, primarily through VAV boxes and small fans. You often wouldn't be able to get a replacement motor for weeks, and that doesn't work in a lab environment like this. But Q-PAC has dealt with that. They've got readily available parts. The thing that I was really impressed by with Q-PAC was their ability to engage with a very, very leery owner. We had an ownership group that, while you could tell they wanted to take the step, they were very, very concerned. And we had several meetings with different experts from Q-PAC, and that's what I can't drive home enough, is they have experts in every single group, be it controls, service, sales. They always have the right person to talk to whoever about their product, and I was very impressed by that. And Matt, I just want to thank you guys again, and thank you for taking the time to spend with us today. And that's really all I have to say.
Yeah, thank you for the invite. It's a great concept. I love what you guys are doing with the coffee break. It's awesome.
Well, thanks everybody, and have a good day.
Thank you for your time. See you guys. Have a good one.